Hello, this is solving quadratics. I did one on graphing a long time ago. This one is just going to be on solving and imaginary numbers in vertex form, getting into vertex form. As you can see, I did the first problem already. That's because I started making a video and then the camera literally just fell off my little stand and I was fumbling around with it for a total of 30 seconds and felt like you didn't want to see all of that. So just to kind of get into what I had done already before I had to stop, was that there are different ways of solving quadratics. Factoring, there's by square roots, there's quadratic formula, there's technically also by completing the square, but that's not on here. When it comes to factoring, the big thing is that it has to be equal to 0. Once it's equal to 0, then you would see how many terms there are and if there's a greatest common factor. So this one, there's no number that goes into all three, so no GCF. Then, since it's 3 terms, you look to see what multiplies to the last number and adds up to the middle number, which is just a 1. And I usually just go through all of the options of multiplying to 12. So like 1 in 12 multiplies to 12. 2 times 6 is 12, and 3 times 4 is 12. But of these options, the only one that'll get you 1 is this, and that's if it's a -3 plus 4. That'll get you a +1, and if you multiply them, you get -12. Since there's no number in front here, this is just a simple type of factoring, meaning if you have -3 and +4, you have x minus 3 and x plus 4 as your 2 factors. Just like that. And then to solve, you just kind of separate this into 2 different equations, being equal to 0. And if you solve from there, just add 3 to both sides and you get x equals 3. Or subtract 4 and you get x equals -4. So that's the simple type of factoring. Once again, it's just what multiplies to -12 adds up to +1. And that's -3 and +4. Set them equal to 0. And the next one, it is equal to 0, which is good. Cha-ching. However, it does have a number in front here, and it's not a greatest common factor because nothing goes into 11. So you have to do what's called the AC method, where you do 3 times 6. And over here in my scratch work, 3 times 6 is 18. And then there's the 11 again. So you want things that multiply to 18 but add up to 11. So what multiplies to 18? Well, 1 goes into it, 2 goes into it, 3 goes into it, 4 does not go into it, 5 does not go into it, 6 is already there. So this is everything that multiplies to 18, and you just see which one would also make 11, which is going to be 2 and 9. So +2 + 9. Unlike the other one, because there is that x number, there's a number in front of x, that means you have to do something slightly different. What I do is I write x's next to them, like so. And you're going to have to do something called factor by grouping in a second. Basically what happens is this 11x right here is going to get split into that +2x + 9x that we found over there. So these two things. The 3x squared gets to come down. The +6 gets to come down. So all of that stays the same. It's just the 11 is getting split into 2 and 9. So that's what's going on. Afterwards, you factor by grouping, like so. You put parentheses around the first 2 and parentheses around the last 2, making sure to keep that sign with the 9. In this case, it's not going to matter too much, but if it was a minus, you would definitely want it inside this one right here. And what you do now is you take out a GCF of each. So like 3x squared and 2x, nothing goes into 3 and 2, but they do both have an x. And if you take out an x, you have a 3x + 2 left. And as for 9x and 6, 3 goes into both of them, so we'll pull out a plus 3. And if you divide these by 3, 9 divided by 3 is 3, and 6 divided by 3 is 2. And you should notice that these are the same. They will 100% of the time be the same. So I'll write down 3x plus 2. And then your other parenthesis is going to be the things outside x plus 3. This is still equal to 0. So that is factored. It's not solved, but it is factored. Factoring is the hardest part. Past this point, you just do the whole set each part equal to 0 again. So 3x plus 2 equals 0, or x plus 3 equals 0. This one, you just subtract 3. This one, you would subtract 2, and then divide by 3. So I would get x equals negative 2/3. There you go. So those are the two answers you would get when you are solving by factoring. Because solving means you get x equals a number. It's not just factoring, it's solving. This one, solved by square roots, the reason you don't have to factor this one is because there's only one x. In these ones, there was an x squared and an x squared and an x. But if there's only one x, then you can just go old school, solve for x, get x by itself. In this case, you could add 3 to both sides, and by could, I mean you will, like so, because those will cross out. And then finally, getting rid of the square. When you have a square, the opposite of squaring is square rooting. So you would square root both sides to get an x. Since you square rooted both sides, you do need to put a plus or minus sign. And then you can't square root a negative. So in some cases you would write no solution, but since this test is also on imaginary numbers, if you ever have the square root of a negative, just make it positive and put an I in front. So it'd be I times the square root of 9. That's how it would be written. Just keep in mind I'm not done yet. Make it positive and put an I in front is what you do. Finally, you can take the square root of 9. The square root of 9 is 3. So your final answer is x equals plus or minus 3i. Just remember numbers go in front of letters, so don't write I3, write 3i. It's just what mathematicians do, numbers first. And it looks like that. Okay, quadratic formula. Here it is equal to 0, so it's already in ABC form. So a equals negative 2, b equals 1, and c equals negative 6. And we're going to be using x equals negative b plus or minus the square root, b squared minus 4ac, all over 2a. So b is 1, so this will be negative 1. 1 squared is 1. I strongly suggest squaring it in your head. That prevents people from accidentally squaring a negative and keeping it negative. Anything squared is positive, so this will always be positive. So 1 squared is 1, minus 4 times a times c, all over 2 times a. The thing underneath, this is called the discriminant, which we're going to need later, but right now you just need to know. It's easiest just to put this all in a calculator in one go. That way you don't accidentally mess up pluses and minuses. Like, for me, I can see, oh, negative times a negative is a positive. Positive times a negative is a negative. So it would be 1 minus something. But honestly, you're probably just safer putting it all in. But as for what it's going to turn out to be, let's see, 4 times 2 is 8. So then you get 48. So 1 minus 48. I'll check that because I'm paranoid. 12. Yeah, that's 48. So then 1 minus 48 is 47. Negative 47. Which, once again, you can't take a square root of a negative. So you make it positive and you put an I in front. 47, you can try to do a number tree to see if you can simplify it, but you can't simplify the square root of 47. So your final answer is just going to be -1 plus or minus I root 47 all over -4. And there you go. The next page is solving using any method you want. We'll get to that in the next one. So, yay!